If you are watching this video, then the chances are very high that you have just taken and failed the percent composition quiz. Why did you fail it? Probably because you were ready for problems like this. You were ready for problems that said, find the percent Na in NaCl, and you could pass that because I gave you the name of the compound and asked you for the percent of one of the elements in that compound. But you've discovered taking this quiz that what if I gave you something else? What if I didn't give you the formula of the compound, but I gave you the name of the compound? And then you have to come up with that. Well, you've already passed the formula writing quiz and the naming formulas quiz, so you should be up to this challenge. But I wanted to shoot a quick little video just to remind you of some of the skills that you should already have. So potassium sulfate. Potassium is K, and sulfate, if you're looking at your periodic table, your polyatomic ions, sulfate is SO4. So there's one sulfur atom and 4 oxygen atoms. So what's the formula? You might say, oh, the formula is KSO4. And you would almost be right. What you need to remember is that potassium, as a group 1 metal, likes to lose 1 electron. And then if you look at your table of polyatomic ions, it says SO4 is -2. So these two things, they don't balance each other out. So what do we need? We need an extra one of these Ks. So the actual formula for potassium sulfate is K2SO4. So if you use your periodic table and you add up all these masses, then you get 174.26 grams. So if you were off by just using 1K, then you would get the wrong answer. So I'm just going to pause this video really quickly and solve the question at hand, and I'll be back in a second. Okay, so I'm back, and I want to be done in under 3 minutes. So here we go. What I already told you was I've got potassium sulfate, and the trick was to recognizing that you had to look at the charges to be able to figure out that you needed 2 of the Ks, 2 of the potassiums to balance out the -2 charge of the sulfate. So I told you that the total mass was 174 and about 1/4, and here's how I did that. I took my molar mass of potassium, sulfur, and oxygen, multiplied the potassium by 2. Oh, I'm not going to make 3 minutes. Oh well. I took the oxygen, multiplied it by 4, and I wound up with a total of 174 and 1/4. So then the question asked for potassium. So I took the potassium number, and that was right here, 78.2. The total was 174.26. And then we just solve for x when we cross multiply our little is over of trick. And you wind up with 44.9% potassium. You might be wanting to know, or you might be thinking, hey, how come he goes out like 3 places here, 2 places here, and only 1 place here and 1 place in the answer? There are people out there, teachers out there, who are like, all right, you have to use this many places, this is significant, that's not. For me, what I would do if I were you is I would, whatever you see on the periodic table, like if it goes out 3 places for potassium, or if it goes out 2 places for sulfur, use whatever your periodic table tells you, do all your math, do whatever you're going to do, and then when you get to the end, give me 1 place. I think when I wrote all of my percent composition problems, I want you to just go out 1 place in your answer. That allows you a little bit of wiggle room back here when you're doing all this other decimal stuff. And when I write these problems, I do try to build in a little bit of a cushion in this decimal place, just in case you do mess up a little bit. So anyway, there's another example, and best of luck on the percent composition quiz.